Hey everyone, and welcome to The Deep Dive, where we take a deep dive into, well, pretty much anything that piques our curiosity.
Yeah, anything that makes our circuits buzz.
Exactly. And today we're going to be diving into the world of electric motors,
All right.
specifically radial flex versus axial flux motors. I'm Nick,
I'm Pi, and I am Team Axial Flex.
and I'm Team Radial Flux.
So we're going to be kind of battling it out a little bit, presenting the pros and cons of each, and hopefully helping you guys understand a bit more about how these things work.
For sure. Now, let's start with the basics. What is a radial flux motor?
So radial flux motor, you can think of it kind of like the classic motor design, right? It's what you've probably seen if you've ever cracked open like a power tool or an appliance or something. It's that cylindrical design, and the way it works is that the magnetic flux flows radially outward from the center of the motor.
Okay, so it's kind of like the workhorse of the industry, right?
Yeah.
It's been around for a long time.
Yeah, very much so.
It's powering tons of devices out there, and it's super reliable.
Absolutely. It's proven technology, it's cost effective to manufacture, and it's super versatile. I mean, they can be used for everything from like tiny little fans to giant industrial machines.
Okay, cool. But there's some limitations, right?
Yeah. So, one of the biggest limitations is power density. So basically how much power you can pack into a given size.
Okay.
Radial flux motors, they tend to have a lower power density compared to axial flux motors,
I see.
which we'll get into in a bit. And the other thing is cooling. So because of their shape, that cylindrical shape,
Hmm.
it can be a little bit tricky to keep them cool, especially when you're running them at high power.
Okay, so that's radial flux, tried and true workhorse of the industry. But a couple of limitations there. Now let's talk about your baby pie axial flux motors.
All right, so axial flux motors, these are the new kids on the block, relatively speaking, and they're kind of like the sleek sports cars of the motor world.
Okay.
They've got this flat disc-like design,
Interesting.
and magnetic flux, instead of flowing radially outward, it flows actually, parallel to the shaft of the motor.
Okay.
And this gives them some pretty neat advantages.
Like what?
So first of all, higher power density, so you can pack way more power into a smaller, lighter package,
That makes sense.
which is why they're really popular in applications like electric vehicles and drones, where weight and size are critical.
Yeah, that makes a lot of sense.
And then the other thing is cooling. So because of their flat open design, it's way easier to dissipate heat, which means they can run at higher power for longer periods of time without overheating.
All right, so axial flux, higher power density, better cooling. What else?
And they're also more efficient. So because the magnetic path is shorter, there's less energy loss, which means you get more bang for your buck, in terms of power output.
Sounds pretty good so far. What's the catch?
Well, there's always a catch, right?
Right.
So the biggest one is cost. Axial flux motors are more complex to manufacture, which means they're generally more expensive,
Makes sense.
especially compared to radial flux motors, which have like super well-established manufacturing processes. And the other thing is that they're not as widely adopted yet.
Okay, so newer technology, not as many people working with it, still kind of under development.
Exactly. Yeah, there's still a lot of R&D happening in the axial flux world. People are
Yeah.
constantly trying to find ways to improve them and make them more cost effective.
So it sounds like we've got a classic trade-off here. Radial flux, reliable, affordable, but maybe not as powerful or efficient. Axial flux, more power, more efficiency, but more expensive and not as widely available.
Yeah, you got it.
So how do we choose?
Well, as always, it depends on the application, right? There's no one-size-fits-all answer here. You have to consider what's most important for your particular need. Is it power? Is it efficiency? Is it costs? All of these factors come into play.
All right, so no clear winner, just different tools for different jobs.
Exactly.
I like it. But what's really fascinating to me is seeing how people are actually putting these technologies into practice.
Oh, yeah. There's some really cool stuff happening out there.
Like, for example, there's this YouTuber who tried to get ChatGPT to design an axial flux motor from scratch.
Oh, yeah, I saw that one.
He was 3D printing parts, winding coils, like the whole 9 yards. It was pretty amazing.
It was a valiant effort.
It was.
Hmm.
But in the end, I don't think it actually worked.
Yeah, it didn't quite work out, but it really highlights the complexity of designing these motors.
Well, for sure, it's not easy.
And then on the flip side, we also saw that project with the PCB stator motors.
Oh, yeah. Those super thin motors built right onto a circuit board.
Yeah, and they managed to get one to spin for like over 1.6 billion rotations.
That's insane.
It's crazy, right? To talk about pushing the limits of miniaturization and durability.
For sure. And you know what? All of this just makes me even more excited about the future of electric motors.
Me too.
Like, who knows what we're going to be able to do with these things in the next few years?
The possibilities are pretty much endless. I mean, imagine motors so small and efficient that they can be integrated into like practically anything.
I know, right? And that actually brings us to a really interesting topic that I want to dive into a bit deeper, and that's the whole world of PCV stator
Yes,
motors.
those are super cool.
They're like the next frontier in motor technology.
Absolutely. So let's take a closer look at those.
Yeah, let's do it.
PCB stator motors. So tiny, so powerful. It's amazing what they can pack into those little circuits.
It really is. But before we get too deep into those, let's talk about some of the other factors that influence motor performance. Things like torque and power density.
Okay, so torque first. Basically, that's the rotational force that a motor can produce.
Right.
And there's this common misconception that axial flux motors always have more torque.
Oh, yeah, I've heard that too.
Right, and it's kind of true in a way because torque is proportional to the radius of the rotor.
Okay, so the bigger the rotor, the more torque.
In theory, yeah, but it's not that simple.
Of course not.
There are other factors at play, like the strength of the magnetic field and the number of poles in the motor.
So it's not just about size.
Exactly.
It's about the whole design of the motor.
Right, and how all of those factors work together.
Okay, that makes sense. And what about power density? We talked about that a bit earlier.
Yeah, so power density is basically how much power you can get out of a motor for a given weight.
Righty.
And axial flux motors, they generally have a higher power density than radial flux motors.
Okay.
But again, it's not always a clear-cut advantage.
Okay, how so?
Well, radial flux motors, they can often achieve higher speeds.
I see.
And speed can compensate for lower torque in some applications.
So it's a balancing act.
Exactly.
You have to weigh all of these factors when choosing the right motor for the job.
Absolutely. There's no one-size-fits-all answer.
Okay, I'm starting to get the picture here, but let's talk about some real-world examples to really drive this home.
Sure. Let's start with electric vehicles, EVs.
EVs. Everyone's talking about EVs these
Yeah,
days.
they're everywhere.
And they all run on electric motors. So which type of motor is winning the EV race?
Well, it's not really a race.
Okay.
Both radial flux and axial flux motors are being used in EVs.
Really?
Yeah, it depends on the specific requirements of the vehicle.
Okay, so what are we seeing out there?
Well, for high-performance EVs, axial flux motors are definitely gaining popularity.
Makes sense.
You know, they're smaller, they're lighter, they're more efficient,
Right.
which is perfect for squeezing out maximum range and performance.
Yeah, I can see that.
But radial flux motors are still very common in more affordable, mass-produced EVs.
Oh, interesting. So it's kind of a cost versus performance thing.
Yeah, pretty much. Radial flux motors, they're still very reliable and cost-effective to manufacture.
Okay. Which is important when you're trying to make EVs accessible to a wider market.
Exactly. So both technologies have their place in the ED world.
All right, so it's another case of different tools for different jobs.
You got it.
Okay, let's move on to another application that's really taking off, drones.
Drones, yeah, those things are everywhere these days.
And they all need powerful, lightweight motors to stay airborne. So which motor type is dominating the drone market?
Well, you can probably guess.
Axial flux,
Exactly. Axial flux motors, they're pretty much ideal for drones.
because of the size and weight thing.
Yeah, and the efficiency too. Drones need to be as energy efficient as possible to maximize flight time.
Right.
And axial flux motors, they just deliver on all of those fronts.
But are radial flux motors completely out of the picture when it comes to drones?
Not entirely. They're still sometimes used for smaller supporting roles,
Oh, interesting. Like what?
like controlling gimbal movements for cameras or other precision mechanisms.
Okay, so it's another example of both technologies working together.
Yeah, each one playing to its strengths.
All right, so we've covered EVs, we've covered drones. Let's talk about another industry that's heavily reliant on electric motors. Robotics.
Robots, yeah, those are pretty cool.
Yeah, they are, from those huge industrial robots to the little collaborative robots, or cobots as they're called.
Right.
They all rely on electric motors for movement and precision.
Yeah, and which type of motor they use, again, it depends on the application.
Okay, so break it down for us.
So for those big industrial robots, you know, the ones that are doing heavy lifting and repetitive tasks,
Yeah.
radial flux motors, they're still the go-to option.
Because they're so reliable.
Exactly. They're tough, they're durable, and they can handle a lot of abuse.
Okay, that makes sense. And what about the smaller, more agile robots?
Yeah, so for those robots, axial flux motors are becoming more and more popular.
Okay, why is that?
Well, they're smaller, they're lighter, which makes the robots more agile and maneuverable.
Right.
And they're also more precise and quieter, which is important for robots that are working in close proximity to humans.
Yeah, that makes a lot of sense.
So again, it's all about choosing the right tool for the job.
Okay, I think I'm finally starting to grasp this whole radial flux versus axial flux thing.
Yeah.
It's not about which one is better. It's about which one is best suited for a particular application.
You got it.
But even though we've covered a lot of ground here, our exploration of electric motors is far from over.
Oh yeah, we're just getting started.
There's so much more to discuss,
Absolutely.
like the challenges of sustainability, the quest for even greater efficiency.
And the mind-blowing potential of emerging technologies.
Yes, exactly.
Yeah.
So stay tuned because we're going to be diving into all of that and more in our next segment.
All right, let's do it.
All right, so we've talked about radial flux, we've talked about axial flux, we've seen how they're being used in all sorts of applications, but what's next? What does the future hold for electric motors?
One thing that's really exciting is the whole world of 3D printing. You know, how that's revolutionizing so many industries.
Yeah, for
Well, it's also having a huge impact on motor design.
Oh, really? How so?
So with 3D printing, we can create these super complex motor designs that were basically impossible to manufacture before, or they were just way too expensive.
Okay, so we're talking about custom shapes, intricate features, things like that.
Exactly. And that means we can optimize motors for very specific applications, you know, tailor them to fit the exact needs of a device.
It's like moving beyond just slapping a motor onto something and actually integrating it seamlessly into the design.
Yeah, precisely. And this is benefiting both radial flux and axial flux designs.
Interesting. So it's not just about one technology replacing the other. It's about both of them evolving and becoming more sophisticated.
Exactly. And we're seeing some really cool innovations in terms of efficiency, power density, even the aesthetics of motors.
Aesthetics? You mean motors that look good?
Yeah, why not? I mean, as motors become more and more integrated into our lives, it makes sense that we'd want them to be visually appealing as well.
Okay. I never thought I'd hear us talking about motor fashion, but I guess it makes sense form and function working together.
Exactly.
But it's not all about looks, right? There are still some big challenges facing the electric motor industry,
Yeah, for sure, like sustainability.
right? We need to make sure that these motors are not only efficient, but also environmentally friendly.
Absolutely. So there's a lot of research going on into using sustainable materials, you know, things like recycled materials and reducing our reliance on rare earth elements.
Okay, so making motors that are good for the planet.
Exactly. And then there's also the challenge of cost. You know, electric motors, especially those with cutting-edge designs, can still be pretty expensive.
Yeah, that's a big barrier to wider adoption.
Right. So the industry is working hard to find ways to bring those costs down, you know, through things like economies of scale, more efficient manufacturing processes, and just continued innovation in materials and design.
So it's a multi-pronged approach, but it sounds like we're moving in the right direction.
Yeah, I think so. There's definitely a lot of momentum behind electric motor technology. And when you combine that with the advancements in battery technology, it paints a pretty exciting picture of the future.
All right, so electric motors are the future. They're efficient, they're versatile, they're getting more sustainable and more affordable. What's not to love?
Exactly. And who knows what incredible new applications we'll see in the years to come.
It's pretty mind-blowing to think about.
Yeah, the possibilities are really endless.
Well, Pi, it's been a fascinating journey exploring the world of electric motors with you today.
Likewise, Nick, I always learn something new when we dive into these topics.
And to all of our listeners out there, thanks for joining us on the deep dive. We hope you learned something new and maybe even got a little bit inspired about the future of electric motors. Until next time, keep those circuits humming.
So next time.